tools. Disruptive technologies are today they are mostly used in many interdisciplinary research. And as a geomatics engineer, as a researcher in this domain, we are integrating different disciplines, basically taking at the center geographic information systems, which we are handling spatial data together with the other technological tools like machine learning, deep learning, and big data analytics, digital twins. So we are basically developing some projects in this framework. So let's start with the problems we are facing in our today's world. We have lots of different problems in the context of increasing population, specifically in urban areas, residential areas. There is a projection to be urban population to be increased up to 70% of the whole lands by 2050s. So this is a critical problem which comes with some side effects like globalization, climate change, biodiversity. So and we are facing lots of disasters. Even in our country, Turkey, we are prone to disasters. So we need some solutions to overcome those effects of different problems. And looking at the global risks prepared by World Economic Forum by a survey in the latest year, we are seeing that in short term, in 2 years, we are seeing geo-economic confrontation. Mostly, we will face with some location-based economic confrontation problems in global perspective, but our country, in our continent and Europe, we will face those mostly. So there is also misinformation, disinformation. So we are saying that data is the new oil to reach out to the information is very critical nowadays. But disinformation is another problem for today's world. So we need to face those problems to overcome them. And we have societal polarization, extreme weather events. Mostly you can see that there is mostly some societal and environmental effect, but in long term, environmental effects are more coming at first hand. We are facing with them like extreme weather event, climate change, biodiversity. So we need to take care of those problems with in data-driven manner. So talking about disasters, United Nations Disaster Risk Reduction Office has prepared some hazard information profiles. So we are facing with different hazard types, like even in geological form, we have seismic effects. We are living in Istanbul city, so we have a critical earthquake risk we are facing with this, and we have also hydrological, meteorological hazards like we have some water-related, temperature-related problems. So how we can overcome to those problems? We need some data-driven approaches. So we can prepare some maps by utilizing geographic information systems, which will be today's major topic we will talk about. So maps are helping us to integrate and apply our knowledge and tell us some stories about everything. Since everything is happening in somewhere, there is location information, and we are trying to model our real world in order to capture, store, analyze, and display spatial data. Data is reference to the Earth. So it is very known phenomenon that about 80% of the data has somehow spatial components, like either a text-based address or either coordinate pairs like latitude and longitude. So we can capture those data, store them in a database, analyze them, and display producing some maps in dynamic structure. After that modeling procedure, we can now produce some strategies based on those data and prepared maps. But using GIS is solely may not be adequate to overcome those problems we have named at the first part of the presentation. So we have some digital environments and data tools we can use and integrate them. For example, we can utilize from building information modeling for the built environment, for physical building data. And mostly we are facing with lots of different data sources, and that is why we call it uh, high volume of the data and lots of various data types in high sizes. So we can name it as big data sources, and 80% of this data has special components, which we call it as spatial data or geospatial data. So we can use GIS together with urban digital twins, which is a replicate of the reality, and building information modeling tools. So that will give us power to more handling more efficiently our built environments or geography. So even inside of the buildings, the whole architectural projects can be modeled, replicated when compared with the reality, and which provides us to creating some simulations based on these data sources. And our presentation title was Sustainable, Smart, and Resilient Cities, and we are doing this with some solutions like geospatial artificial intelligence techniques, and we can use some base solutions, some reality mapping, digital twin of reality. So after this modeling phase, we can now talk about digital twins and apply some smart city components to those base models. After replicating the reality, we can create digital twin of our cities and then overcome some environmental problems, for example, flood risks or even wildfires, earthquake risks. Those can be named under disasters, and lots of different social, economic, or physical problems we can may encounter. We can solve those by integrating those disruptive technologies. So of course, there are some steps for preparing this digital twin platform. First, we need to start with creating a descriptive visual twin, which we call it as reality mapping. So basically, we need data, spatial data, to acquire those data and build a model on the top of it to create digital twin. Then we can overlay some different data sources to integrate them, which enables us interoperability to work with different data sources, fuse them to solve those problems. And we can connect any open data sources, APIs, or even we can use some IoT sensors, which gives us a real-time feed our data to build some solutions, applications on the top of these steps. So talking about smart cities, we have different use cases, different elements and components under smart city solutions to overcome those named problems. Even we can create electrical vehicle charging location selection problem by utilizing geospatial artificial intelligence, smart parking management, public safety, smart energy, to observe current energy efficiency of our buildings, or maybe improving it by some retrofitting actions, waste management, smart building, air pollution. There are lots of different application to be carried out by utilizing this digital twin based smart city approaches by utilizing geographical information systems and artificial intelligence techniques. So there are some detailed use cases about the components. So remember, we had the first step of the creating digital twin was reality mapping. So it was basically creating an accurate digital representation of the physical world using images. We can even using LiDAR technology, light detection and ranging technology, even drones, aerial or satellite imageries. And basically we can fuse those different data sources to create our digital twin. That is why we call it reality mapping. And there are also different stages like analysis of this gathered data, acquired data. We can apply some classification, change detection, proximity analysis. Different location-based analysis can be applied, and we can visualize the results outcome of this analysis, even in web-based or cloud-based platform, to feed users perspective to give them the results of what we are doing in our projects. So recently there were some developments in the AI and geospatial artificial intelligence techniques. As you already familiar with the AI, it enables simulation of human intelligence, and there is also progress in AI. Today we are talking about general artificial intelligence, and nowadays we are facing with generative AI, conversational AI, natural language processing. Under that, we are using mainly large language models, and we are also integrating those methodologies in our discipline in geomatics engineering to be used with GIS with artificial intelligence. So as you can see, nowadays we are talking about LLM models, and those are frequently used in geospatial domain as well. So, what is basically GeoAI? It is geospatial artificial intelligence combination of the GIS technology, location-based analysis, analytics, together with the AI. So, what we can create with GeoAI technologies and applications, for example, we can handle with text-based data like text classification, utilizing from tweets, X tweets, to do sentiment analysis, and doing this with location-based analytics to infer from which users are affected by some disasters, for example. We can even do some classification like land cover classification by utilizing satellite imageries to observe the current land use changes in the historical time series data. We can even create regression models, which are spatially dependent models. We can develop some prediction models by GeoAI. Even we can utilize imagery and video data sources like change detection of the land surfaces, pixel classification, point cloud classification, and extraction of some objects from satellite imageries, for example, building or any other objects can be easily extracted from satellite imageries under GeoAI applications. So of course, in the development of the machine learning, GIS software also has integrated those technologies. And recently, we are seeing that pre-trained AI models are frequently used in this domain. So we can easily integrate our data sources to the pre-trained models. We can achieve high accuracies for applying those different GeoAI techniques. Even in building extraction, you can use pre-trained models, which will decrease the processing time very in very short time. You can achieve accurate results, highly accurate results by utilizing geospatial AI techniques. So solely using AI will provide us, sorry, let me continue. Solely using AI will only give us some power to see, read, learn, create an analysis of the data, but utilizing from the land-related data, spatial data, GIS data, we can have much more power when including location components to our data. We can analyze further to see some solutions with the GeoAI, like the one I have mentioned before. We can even apply cloud removal to satellite imageries. That is also one of the applications. Increasing the resolution of the satellite imageries, 3D reconstruction of the city models, of the mostly applied techniques for creating GeoAI models. So we can create a digital twin of the cities, urban areas by utilizing GeoAI. So that is why they are integratable technologies, which we should also utilize them together to create end-to-end GeoAI system. So as I mentioned before, there are some stages to apply this technique. But when you use pre-trained models, you will see that you are gathering very rapidly to outcome of the analysis. So what we are basically using GeoAI for classification, clustering, either in prediction models. So even in GIS softwares, those machine learning tools are integrated for users to easily analyze, for example, spatially constrained multivariate clustering to be applied for spatial data, space-time cubes, hotspot analysis. So mostly the data input is GIS spatial data for us. So in deep learning, imagery tools also can be applied. As you can see, there are different deep learning algorithms that integrated to be used for GIS data sources, like in UAV drone imageries or satellite imageries can be applied feature extraction or change detection. Lots of different applications like YOLO algorithms can be applied easily in GIS platforms. Even in notebook files, you can integrate those with pre-trained GeoAI models. So you can see that labeling, data preparation, train model, and inferencing stages are not in our focus when we are using pre-trained models. So we have Esri company, which is a dominant GIS company, produces GIS softwares, ArcGIS. They have integrated some lots of different AI models and architectures to GIS. So you can use ready to use those tools in GIS. Let me show you some examples. Even in web platforms, you can simply apply some applications of GeoAI by utilizing your web platform. So here is an example to segment anything model for GeoAI. You can gives inputs of the satellite imageries, agricultural land parcels, and you can extract the boundaries of those land parcels by utilizing these pre-trained GeoAI models. So easily you can have this in minutes. So we can also use tree segmentation, combining tree detection model with this SAM model. You can extract trees easily from the satellite imageries. And you can also integrate this data with your current databases. So LLMs are very popular nowadays. You can use some text prompts to support this grounded SAM model to extract some features from the data sources, imageries. Like you can see, there is text prompt, circular object extraction, and you can arrange model parameters to easily extract new data from given data sources. And here is you can also extract airplanes from satellite imagery, again, by utilizing this SAM model used inside of the GIS software. So here is an example of building footprint extraction using Sam LoRa model. And you can take these footprints to be used in another project framework. GeoAI tools can ease your data handling processes with some accurate deep learning solutions integrated into GIS frameworks. So let me continue with my presentation. So I will also mention about a case study based on this sustainable, smart, and resilient cities. In the resilient part, we should also taking into consideration disaster management related problems. So we are living in the age of multiple disasters. So we need to manage our disaster risks to improve the governance. According to the United Nations Office of Disaster Risk Reductions, we need to invest more to disaster risk reduction efforts before we are facing with crisis. So GeoAI techniques utilizes to handle this risk analysis to see what are our risks and how many people will face with those risks if those disasters are happening in somewhere. So there are some steps of disaster risk management with geospatial artificial intelligence. So we have lots of, again, data layers, like you can see, which represent some different parts of the cities. We can have either tree spaces, buildings, roads, rivers, and we are collecting those data from different measurement techniques like airborne LiDAR, IoT sensors, APIs. So we need to handle this big geospatial big data. And identifying a problem stage, we are doing analytics like data pre-processing stages, spatial data, exploratory data analysis techniques, and real-time modeling stages are important to better know about the data to be used in our simulation and analysis. And third stage is the simulation after gathering the data and modeling it. Now we can create some multi-objective optimization and smart decision support system. So GIS is also known as a powerful decision support system. So utilizing this spatial analysis, a robust spatial analysis feature of the GIS, we can create hazard analysis and we can also apply some risk analysis techniques to use those GeoAI tools and frameworks. And lastly, we can create web-based geovisualization tools for early warning purposes or stakeholder engagement to inform citizens about their risks where they live. So looking AI methods which used in different disaster management phases. So we are today focusing on in our project as well migration phase, disaster risk reduction phases. So basically we are doing risk assessment, hazard forecasting, and evaluating those impacts of the hazards and vulnerability assessment and some mitigation strategies. So at this part, we can name it as before happening the disasters, we can take some precautions, analysis our risks and mitigate them. So this is a critical stage and we can utilize from geospatial artificial intelligence techniques to do automated decision-making tools and frameworks. So how it can contribute to disaster management in terms of risk analysis and mapping, we can utilize in different disasters like fires. We can model the weather, vegetation type, and modeling of the spread. And we can also have some cascading effect, like citizens, buildings, and road accessibility can be measured, analyzed with GeoAI. And in floods, we can model weather forecasts to inform citizens about the flood regions, the effect of the floods and some catastrophic effects as well. And in pandemic we have faced in 2020s, we can also model the sickness trend in infection rate using GeoAI. And in earthquake, for example, we can do model forecast models, estimated population density, and observe the affected areas by using our simulation models utilizing GeoAI. But nowadays, we are seeing that lots of AI agents are developed for some specific solutions, specific tasks, which they are very beneficial to be used in GeoAI contexts. So AI agents provide some systems that operate continuously, process the data autonomously, and generate automated actions for risk prediction and prevention for our use case. So in the first stage, we can have a risk prediction agent for disaster management with GeoAI use case. So it can continuously analyze the climate data, like in meteorological stations, we can have precipitation data, temperature and wind data to forecast long-term disaster risks. And to give an example to this flood risk agent, it can process 30 years of historical and hydrological data to update these high-risk inundation zones dynamically. And secondly, infrastructure monitoring agents can enable preemptive identification of structures approaching some critical safety thresholds. And another agent, environmental change agent, can analyze some land use, deforestation, urbanization, which can affect each other in terms of those environmental shifts may increase susceptibility to another disaster like landslides or flash floods. So at the end, we can have scenario simulation agents. It can automatically execute some disaster scenarios, such as if 100-year rainfall events recurs in the specific region, for example, in Edirne province, this number of buildings will be impacted. It will give us the results of the scenarios for specific disasters. And we can also utilize from the AI assistants, which they are beneficial to supportive AI assistants to provide some accessible and comprehensible information to human experts, local authorities, and general public. And it can give us to empower advisory for decision makers, like flood risk in Sarıyer district of Istanbul is very high. Flood protection infrastructure is required in this area by 2030s. So in nowadays, with the further development of the AI, we can utilize those AI agents in our geospatial information technologies, data handling approaches as well, and it can be beneficial to overcome those disaster management problems. So we have published a paper related with this flood risk analysis by using explainable geospatial artificial intelligence techniques recently. So as I mentioned about some different data sources, we can have data providers of, for example, General Directory of Meteorology. We can have different institutions that produces GIS spatial data. We can overlay those data layers to create hazard and vulnerability assessments. So we are utilizing from Python-based frameworks like GeoPandas, NumPy, Matplotlib, and nowadays we are using different, apart from traditional approaches, we should also integrate geospatial big data approaches like ParQ format is very beneficial for handling vector-based data. For even raster sources, we can have cloud optimized geotiffs. We can use this kind of technologies. We can handle big data sources to integrate them and analyze them. For AI part, we are using geospatial data sources, which will make our model spatially explicit AI models. So we can use any prediction or classification models like random forest or XGBoost for for creating flood hazard raster and flood vulnerability maps at the end for risk assessment of the flood risk. So we are creating a flood risk map as an outcome of this workflow. So different data layers we have used to analyze flood risk in Marmara region, including Istanbul city. We have 11 cities in this specific region, and we have acquired different data layers from different data providers, data creators, and carried out some special analysis processes to create hazard map and vulnerability map at the first end. As you can see, we have different criteria that may affect the flood risk, and we have prepared those layers, assessed them with GIS, and created hazard map, like including waterways, proximity, slope analysis. As you can see, in areas with low slopes, water accumulates, increasing the risk of flooding. So we have flood direction layer, precipitation layer, aspect, flow accumulation, elevation, and water bodies proximity. And those are each of those data layers are processed, analyzed in GIS platforms. Even in open source QGIS softwares, you can do this kind of analysis. Or in notebook Python environments, you can also apply those analysis parts to create this hazard map. So in the hazard map part, we have used analytical hierarchical processing technique to create the hazard map with overlay of different layers. And then,
do you prefer the questions to be asked at the end, or can we ask questions during your presentation?
I have a few slides left. It will be beneficial at the end. I can answer the question. So at the second stage, we have vulnerability mapping production stage. For this stage, we have used flood inventory data. So recently happened flood events. We have acquired this data from the relevant Ministry of Urbanization. So we have used those for training our machine learning model in GeoAI perspective. And we have again used different criteria for vulnerability map, like topographic ruggedness index, topographic wetness index, stream power. And those are mainly indicating the vulnerability susceptibility towards the floods, like population, land use, precipitation. And we have trained our model with past 50 years of flood data, and by using random forest and XGBoost methodologies. Again, you can see the each analysis outcome of the different criteria included in vulnerability stage. We have different criteria here: drainage proximity, population, precipitation, land use. Each of them has somehow an effect to the flood vulnerability, at the end, flood risk. And then you can see that by overlaying those different map layers, at the end, by using some probabilistic scores of those vulnerability to flood risk, we have prepared this vulnerability map, which will be combined together with the hazard map to create a risk map. So we have used random undersampler approach to overcome the class imbalance for this flood example. And you can see our results of the machine learning models, performance metrics, accuracy, precision, recall, F1 score, and area under curve results. We have created confusion matrix. You can observe the results are very accurate in terms of applying classification model for flood risk analysis. So at the explainability part, thanks to shapely additive explanations shape model, we can analyze each of effect of each feature to our classification model. For example, in either negative or positive effects, we can also observe feature value low, relatively low or high effect. So drainage, proximity, elevation, and land use was very effective parameters for creating this flood vulnerability map with GeoAI. So there are some different GeoAI resources. I have shared them in the last section of my presentation. I have mentioned about ArcGIS S3 company. They have very useful uh, resources for utilizing geospatial artificial intelligence techniques. And even in open source sites, we have different resources like GeoAI. GeoAI library is a powerful Python package for integrating AI with geospatial analysis. And you can see some example like text prompt segmentation or solar panel detection from the satellite imageries. You can also have a look at those resources to further details of the GeoAI. Thank you for listening. Now I can answer